Good morning, everybody. Uh, so today we'll be doing mechanics. All right. So in this scenario, we have a block A with a mass of 4 kg that is at rest on a rough horizontal table. So this object is resting on a rough horizontal table. That means it will experience a frictional force, a kinetic frictional force when it is moving. But since it is at rest currently, so it is experiencing static friction. Okay, so now this block A is connected to another block B with a mass of 8 kg by a light inextensible string passing over a frictionless pulley. So now this string is inextensible and it is light, meaning that we can ignore, or that simply means the tension will be constant. So this string cannot stretch. So the tension will be constant. The tension at A, at block A, and the tension at block B. Okay, so now a force F1 of magnitude 96 is applied vertically upward on block B as shown in the diagram below. There. Okay. Then a force F2 of magnitude 75 is now applied at an angle of 25 degrees with the horizontal on block A, and the block accelerate to the left. Okay, so block A accelerate to the left. That means now block B will accelerate downward. The kinetic frictional force on block A is 11.76 newtons. Ignore the effect of air friction. So now the frictional force which is experienced by block 4 kg will be opposing the motion. So it will be decelerating our system. So it will be it will point in the right direction, not in the direction of F2. It will oppose F2. Okay, so now 2.1, we need to state Newton's second law of motion in words. So Newton's second law is simply equal to F net is equal to ma. But now we need to state this law in words. So what does this mean in words? It simply means that when a net force, this should be the net force, when a net force acts on an object, so the object will accelerate in the direction of that net force with an acceleration that is directly proportional to the mass of the acceleration of the object, and inversely proportional to the mass of the object. All right, so that's Newton's second law in words. Okay, now 2.2, we need to draw a labeled free body diagram for block A. Okay, so block A. Okay, let's first draw our surface using the red pen. So that's our rough surface. Then on top of this rough surface, we have a block. So we're going to represent this block as a dot. Then now the surface is going to exert a force which will be normal to itself or perpendicular to itself. So it will point upward. So the normal force will be perpendicular to the surface. Then this surface now is rough. That means we're going to have a friction which will oppose the applied force. So it will be on the right. Okay. Then we also have a tension which will be on the right also, which is connecting those two blocks. Then we are going to have a weight force which will be pulling the block downward. Then finally, we're going to have the force F2, which is acting at an angle of 25 degrees. Now I can rub my surface. Then we are done. 1 mark, 2 mark, 3 mark, 4 mark, 5 marks. Oh, 1, 2, 3, 4, 5, 5 marks. Okay. Then we should also draw another free body diagram. Okay. Even though we are not asked to do that, but we should also draw that free body diagram for the second block. So the second block, okay, before we even draw the second free body diagram for the second object. Okay. So let's determine our directions. Oh no. So we're going to choose the direction to the left as positive, because this is the direction of the of the acceleration. Therefore, the direction to the right will be negative, because it will be opposing the forces that are going to the right, are opposing the motion of the object. Then let's now split, because this force is acting at an angle. So we're going to split it into its component. So this will be the x component of F2, F2x. Then we're going to have an upward y component of F2. This will be F2y. Then here we're having the normal force. All right. So those two red components which I have drawn in red are equivalent to F2. Okay. Then everything that is going to the left is positive. Then everything that is going to the right is negative. Then let's draw now another free body diagram for the second object. So now, since the block will be accelerating downward, so we're going to choose downward as positive. So the forces that are pulling our object downward is the weight and also the tension. Then the one that will be upward will be F1. Okay, so this direction will be negative, and this one will be positive. Okay, then let's try now to answer the next question. 2.3. We need to calculate the magnitude of the acceleration of block A. But block A and block B will have the same acceleration, because this is a unique one system. So both block A and block B will have the same acceleration. Okay, so now we're going to solve this question simultaneously. We're going to have two equations, and we're going to solve those two equations simultaneously. So let's start with this one. So we're going to apply Newton's second law. So F net is equal to ma for block B. Okay, then what are the forces that are acting on block B? So tension will be positive, and also weight will be positive, but they are going to be opposed by F1 minus F1. This will be equal to the mass of block B, which is 8A. All right, then tension, we don't know the tension, but we know the mass. Weight is equal to mg, and we know the mass, it is 8. Then gravity is 9,8. Minus F1, we know F1 is 96 newtons. This is equal to 8A. Okay, now let's make T subject of the formula. Then using our calculator, we shall first simplify the numbers. So we have 8 times 9,8 minus 96, which add up to 17,6. This is equal to 8a. Therefore, the tension will be equal to 8a plus 17,6 newtons. So that's our tension. Then we are done with the first block. So let's move to the second block. Now applying Newton's second law again, F net is equal to ma. All right. Then what are the forces that are acting on block A? Then on block A, let's go back to the free body diagram for block A. Then the acceleration is in the x direction. So in this direction, which I'm going to highlight now. Then we're going to add all the forces that are in that direction. Then we're having the x component of F2, friction and tension, but friction and tension are opposing that x component force. Then we're going to have, let me change the color. We're going to have F2x, which is opposed by tension and frictional force. This will be equal to ma. Then what the mass of block A is 4. Then we're going to have A. Okay. But what is F2x? All right. So let's go back to the free body diagram again. Okay. Then we have this angle here. So let's say that angle is 25. So what I'm going to do, I'm going to move this component, the y component, and put it here, without changing its magnitude and direction. So now I have formed a closed right-angled triangle. Then now I can apply trig ratios of Pythagoras theorem. Then here I have F2x. Okay, let me use the red color. I have F2x. Then here I have F2y. Okay, I want this x component here. So this is my adjacent to this angle. Then F2 I know, and it is the hypotenuse. So I can take cosine of theta. Then cos of 25 degrees will be equal to F2x over F2. Then F2x will be equal to F2 cos 25 degrees. So in the place of F2x, I'm going to put F2 cos 25 degrees. Okay, so F2 cosine of 25 degrees minus tension. We know tension, it is that one over there. So it's 8a plus 17.6. Okay, minus frictional force, which was given to be 11.76 newtons. Okay, this is equal to 4a. Okay, what is F2? F2 is 75. So I'm having 75 cos of 25 degrees minus 8a. Now we are removing the brackets. Then this negative times that positive is going to give us 17.6, which will be negative, then minus 11.76. This is equal to 4a. Now I'm going to transpose this 8a here, and it's going to be positive to the on the other side of the equation. Then I'm going to have 75 cos 25 degrees minus 17.6 minus 11.76 is equal to 4a plus 8a, which is equal to 12a. Okay. Now I can, all right, okay. So we are having 12a on the right hand side. Then now I'm going to simplify the numbers. Okay. Then I have 75 cosine of 25 minus 17.6 minus 11.76. So this is equal to 38 38, 0.6130, 8403. Then I'm going to divide by 12 both sides. Then my acceleration will be equal to 3.22 meters per second squared. Then that's our acceleration for block A. Then we're done. Then 2.3.2. We need to determine the tension in the rope connected to block A. In the statement, they said the string is inextensible, meaning that the tension on block A and block B should be the same. So we're going to use the tension for the first block, which is block B. Then according to block B, the tension should be equal to 8A plus 17.6. 8A plus 17.6. Then our acceleration is 8.22 plus 17.6. Therefore, the tension should be equal to times 8 times 8.22. Oh no, 3.22. 3.22 plus 17.6. Then the tension should be equal to 43.36 newtons. Then it will be downward for block B, but it will be to the left for block A. Then we are done with this question.